the Earth Science Classroom, looking at Earth's interior, looking at how to create melt or magma. Now, as discussed in a previous video, this diagram, which you'll see in various websites and textbooks regarding the geothermal gradient versus partial melting, how rock can go through changes where the temperature increases to a point where it can actually melt over the pressure and depth of the surrounding environment and lithospheric pressure, and it can go through various stages of partial melting, differential melting, and the creation of different kind of magmas. And again, it relates to the Bowen's reaction series with the minerals crystallizing, and also the creation of melt, which goes into volcanology, subduction zones, hotspots, rift valleys, you name it. So this is really a key thing to understand what happens to the rock, what is added to the rock, because if you look at the regular geothermal gradient, like this, so we have our regular or normal geothermal gradient. Now, gradient is slope or degree of angle, how fast things change based on depth and pressure. So you can see that as temperature increases and pressure and depth increase, there is a certain line in which the rock remains. So basically the rock is going to remain solid regardless of how deep it is because of the pressure and regardless of how hot it is. It's going to remain basically solid. So something's going to have to happen or be added or changed to the rock in order to take this red line and push it this way and over into the partial melting. So the temperature has to be increased, or this green line, this Solidus line where the rock starts to melt, has to be brought this way and changed to go over. So there's going to be some sort of change or meeting point between either the geothermal gradient changing or the Solidus line changing. And that happens in two main ways. First, you have to raise the geothermal gradient, as discussed. But how? Well, there's four main ways we can do this. Okay, I'm gonna put I there. Okay, so I. So decompression. Decompression is where the rock is moved towards the surface to decrease pressure and allow the lithostatic pressure to drop, allowing the rock to change that thermal energy into kinetic energy, allowing the molecules in the rock to move more and start the phase change and partial melting from a solid to a liquid. And decompression is where it goes to, basically it decreases the depth, so it goes towards the surface and allows pressure to reduce, allowing the changes to occur. And that could happen through convection currents, it could happen through upwelling, it could happen through various uplift, depends on the depth and the location. The next one we'll look at is convection currents, which mainly happen in the plastic, kind of less rigid asthenosphere, which we'll discuss more in a later video. The convection currents will bring up, again, towards the surface, which again relates to decompression, the material, allowing the viscosity and temperature to change. And the third one is radioactivity. So about 80% of the Earth's internal heat or heat flow comes from the decay of unstable isotopes in various elements inside the Earth, such as is uranium and thorium, radon, and potassium. So these four main elements that are unstable isotopes are going to break down with alpha and beta decay and create heat. And this heat flow is going to move up and it's going to change or raise that geothermal gradient. And the last way we can raise this gradient is by, number 4, is by frictional heat. Now, frictional heat comes from the mostly in subduction zones, where you have the two slab, or the slab that's subducting, the heavier, denser slab that's subducting, is going to grind or move or push past that other plate, be it continental or oceanic, and the subduction process is going to cause a lot of frictional heat that would melt not so much the slab, but actually melt most of the non-subducting, the floating uh, um, uh, crust, as opposed to the actual subducting slab. So frictional heat can add to this as well. So at certain depths, usually between 100. So what you get is these 4 things usually work within the depth of 150, 250 kilometers. Or in terms of the seismic changes, would be termed as the low velocity zone, where we get that decrease in seismic wave propagation or velocity, inferring that there is enough heat flow generated from these 4 different possibilities to raise the geothermal gradient up towards the solidus and create a partial melting environment at this depth. Now, it could occur in different depths, but this is where the most of it is occurring, and it's just below the lithosphere and in the top part of the asthenosphere. Now, as I discussed earlier, the other way we could do this to create magma or melt and partial melting to occur is to take the Solidus green line and move it further towards, and move it left towards the geothermal gradient. So you're going to lower the Solidus line, as opposed to raising the geothermal gradient. If you want to lower the Solidus line, you have to add things to the environment and in the rock in order to do this. And the 2 things that you can add, so 1 and 2, there we go, is our volatiles. In terms of water, being the main one, and volatiles in terms of CO2. So these 2 gases, or in terms of liquid water, this is going to happen in certain areas. So you have, again, subduction zones over oceanic crust. And you have it in a location where the trench is formed too. We have that addition of ocean water in small amounts being squeezed and drawn into the rock during subduction, and that inclusion of water and dissolved gases and volatiles is going to lower the solidus and be able to start melting the rock at a lower temperature, as opposed to raising the gradient, the geothermal gradient. It's a different way of doing it. So there's 2 main ways, and inside the Earth, it depends on different location and quantity, but you can definitely create a small amount of melt this way. So what's going to look like is, rather than having the normal gradient here, so normal here, you're going to actually bring this either up towards the increase the gradient, or you're going to decrease the solidus line, and this will be your effect, where you'd have an area right here in blue. You have increasing partial melting of that rock, starting at this depth and this pressure line, and starting at this temperature. So you have certain aspects that can create the melt required to fuel our hotspots, our volcanoes, and create also some of the earthquakes we experience. All right, guys, thanks for listening. I hope you understood this, and it's a better way to look at these diagrams and what can change how we create melt. Please subscribe to the channel and leave a comment. Thanks.